Hey everyone, and welcome to 10.6 Notes. 10.6 is the last section in Chapter 10, so if you have questions, make sure you are asking those. It is all over segment relationships inside circles today. So segments of a chord are what we're going to focus on, which is when two chords intersect in the interior of a circle, and each chord is divided into segments. So notice the diagram below. Okay, we have two chords intersecting each other, and therefore I have multiple segments that are created. If two chords intersect in the interior of the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So what that means is in this picture, from A to E, so AE times E to B, that's one product, should be equal to CE times ED. Okay, so you're taking each section of the chord, saying if I multiply those together, it should be the same as if I multiply those other two segments together. Okay, so what we're going to do is actually practice with that equation. So you're multiplying across the chord. Okay, so for the first one here, here's one chord, so I have 4 times 3 equals, and then I have my other chord, 2 times x plus 1. Okay, so you're finding the product there. I'm going to go ahead and distribute and simplify. So I have 12 equals 2x plus 2. I'm going to subtract my 2 from each side, so 10 equals 2x, and divide by 2. So in this one, when I find the value of x, I get 5. Okay, for the second example, I'm going to follow the same formula. So I'm going to start, and it doesn't matter which chord you start with. I'm going to start with going across this time. So I have x times x plus 4 equals, and then here's my other chord. So I have x plus 2 times x plus 1. And now I'm going to simplify those. So on the first part on the left, I'm going to distribute. So I get x squared plus 4x equals. On the right, I am going to have to FOIL this, so I end up with x squared plus x plus 2x plus 2. Okay, combine those like terms right there, so I get x squared plus 4x equals x squared plus 3x plus 2. Okay, and then I'm going to subtract over my x squared. I notice that both of those cancel. I'm going to subtract my 3x over. So 4x minus 3x gets me x equals, and 2 is all I have left there. Okay, just make sure that you are aware of what the question is asking. So at this point, because it says x equals 2, I want to double check that I've answered my question. Okay, not quite on this one. So it says what is ML and what is JK. So that means I'm going to plug in my value. ML is the entire chord there. So I have 2 plus 2, that's 4, plus 2 plus 1, so I end up with ML is 7. And then I'm going to do the same thing for the other chord. So I have 2 plus 2 plus 4, so JK equals 8. Okay, so now we're going to talk about tangent segments and secant segments. Okay, so a tangent segment is a segment that is tangent to the circle at an endpoint. So notice it's tangent to the circle at the endpoint. Okay, it is only going to hit the circle one time. Remember, that's what a tangent is. Okay, your secant segment is the segment that contains a chord of the circle and has exactly one endpoint outside of the circle. So notice in the diagram, my secant segment is the whole thing. And then I have what's called the external segment, which is just the piece between the circle and that exterior endpoint. So the first type that we're going to talk about is when we have two secant segments. Okay, so both of them are going through the circle if they're secants. So if two secant segments share the same endpoint, okay, that's endpoint E here, outside of the circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So remember, the whole thing is the secant, and then the external is the part between that exterior endpoint and the circle. So what that looks like in a formula for this picture is EB times EA is equal to ED times EC. So you have the entire thing times the outside equal to the entire thing times the outside. We also have the option where we could have a secant and a tangent together. So if a secant and a tangent segment share the same endpoint outside of the circle, then the product of the lengths of the secant segment and its external segment, so that's very similar to what we just saw above, equals the square of the length of the tangent segment. So that's what's new. Okay, so I'm going to start with my secant segment down here that goes through the circle that says the entire segment times the external piece is equal to the square of the tangent segment. So that would be EA squared. So when we look at examples, the first thing we have to do is identify what kind we have. Do we have two secants or do we have one secant and one tangent? So for our first picture, we have two secants because we see that both of those lines are going through the circle. So what I have to do is make sure I figure out what the entire secant segment is, because that's part of my formula. So for this one, from R to Q is 9 plus that 11, so I get 20 total here. And then on the bottom, you have 10 plus X, so that would be your entire secant segment. So for this first one, we're going to do the entire segment on top times that exterior piece, which is 9, equals the entire segment on the bottom times the exterior piece, which is 10. Okay, so what I'm going to do now is I'm going to distribute that 10, and I'm going to simplify 20 times 9 gets me 180 equals 100 plus 10x. I'm going to subtract my 100 over, so I get 80 equals 10x. And when I divide by 10, I get that x equals 8. Okay, for the second one, again, I have two secants. So what my first step is going to be is figure out what the entire thing is. Remember, that is just like adding those two pieces together. So I have 3 plus x plus 2, okay, which is the same thing as x plus 5 here. And then on the bottom, I have x plus 1 minus 1, okay? So that's going to simplify all the way down to 2x. So when I set up this problem, remember you have the entire thing, so on top that's x plus 5 times 3, that's the external piece, equals the entire thing, that's 2x, times the external piece, x plus 1. Okay, and now I'm going to distribute on both sides, so I end up with 3x plus 15 equals 2x squared plus 2x. Okay, so this time I notice that I don't have an x squared on both sides. My x's aren't going to cancel, so this one is actually a problem where I'm going to have to either factor or use the quadratic formula in order to solve. So that means I need to get everything to one side. So I'm going to subtract my 3x over, and I'm going to subtract my 15 over. So that gets me 2x squared minus x minus 15. Okay, so I'm going to go ahead and factor this one, because this one is factorable. So I get 2x plus 5 equals x minus 3. Remember, to solve these, we set each piece equal to 0, and then we solve them individually. So this one would end up with x equals a negative 5 halves, and x equals a positive 3. Okay, now what I want to do is I want to make sure that both of those make sense in my equations. So if I plug in negative 5 halves right here, okay, that's a negative 2.5, then I would end up with a negative segment length. which does not make sense. So in this one, we are going to cross out the negative, and we only have the option for x equals 3. Okay, we can't have a negative segment length, so make sure if you plug it back in that it makes sense. If not, it's not an answer. Okay, here we have a couple examples where we have one that's a segment or secant and segment and one that's a tangent segment. So remember, we have the whole secant, that's x plus 5 here, times the outside is going to be equal to this tangent segment squared. So that's going to look like 5 times 5 plus x equals 7 squared. Okay, and I'm going to go ahead and distribute. So I have 25 plus 5x equals 49. I'm going to subtract my 25 over. So I get 5x equals 24. And then when I divide by 5, I get that x equals 4.8. Okay, it says round to the 10th, so 4.8 okay, is okay as an answer. Okay, for the next one, I'm going to set it up the same way. So here's my tangent segment. Okay, so I have 16 squared. On the bottom, I have my secant, so I have x plus 8, and then I have my x as my external piece. So I'm going to go ahead and distribute that. So I get x squared plus 8x equals 256. I notice that none of my x's or x squareds are going to cancel, so I'm going to get everything onto one side. So I get x squared plus 8x minus 256. Okay, and this one actually does not factor. So what we're looking for is actually to plug it in to our quadratic formula. Okay, there are plenty of programs that do the quadratic formula, so remember if you have your graphing calculator, you can plug all of your a, b, and c into that formula. If not, then you can do it by hand. Okay, on this one, it's going to simplify down to -4 plus or minus 4 radical 17. And remember, we only can have a positive answer because if I have a negative, that would make that segment negative out there. So rounding to the nearest 10th on this one, I would get x equals 12.5. Okay, last two. Again, I have one where it is a tangent and a secant together. So my whole secant looks like 4 times the exterior, that's a 1, equals my tangent segment squared, so x squared. So this time I'm going to take the square root in order to figure out what x is, and I get that x equals 2. Square root of 4 is 2. Okay, and last one, this one I have 2 secant segments. So I need to make sure I find the totals on both sides. So when I set this up, I'm going to have 50 times my exterior is 15 equals 29 plus x. My exterior is x. Okay, again, it doesn't matter which side of the equation you put those on, which one you start with. It's always going to end up the same. So I have 750 equals x squared plus 29x. Again, I don't see an x squared that's canceling or an x, so I'm going to get everything to one side. And then I notice this one also does not factor, so again, I'm going to put that into my calculator in order to figure out what that looks like in the quadratic formula, or I'm going to do the quadratic formula by hand, which remember is -b plus or minus the square root of b squared minus 4ac over 2a. You're plugging it in, a, b, and c. And when you simplify to get the positive answer, because I can't have a negative length, I get 16.5. That's rounded to the nearest 10th. Hey, make sure you guys are asking any questions that you have. Again, your homework is on Clever. You will have a test over Chapter 10 next week, so make sure you're asking, emailing, or Teams questions. Thank you.